The circles video? Oh, I remember that like it was yesterday. It was the fall of 2017. I had been working on my old YouTube channel at that point for a while, and I had been making math videos for my classes, and I was making what I considered to be my magnum opus, my most important math video. Circles. It was dark, it was gritty, it was going to change the way the math lessons were seen on film. But the people who ran my YouTube channel, they wouldn't have it. They wanted me to change it. They brought in a new writer to add jokes, make it lighter. Not to go off on a tangent. No one was able to see my true vision. That is until the fans. Until people like you. You, with your release the Peacock cut tweets. You're the reason why this is going to be available. Now I made some changes. Things that were in the light are now in the dark. It's longer. I've added chapters. Most importantly, I've done the aspect ratio I wanted. But here you go. My Peacock cut of circles. This is geometry. Now recall that a circle is the set of all the points in a plane that are equidistant from a given point. In other words, basically every point on the line, well not line, but every point on the circle is the same distance from the center of the circle. A circle with center C we would call circle C, which we can either write as circle C in words or with the symbol, which you can see right up here. The interior of a circle is the set of all points inside the circle. The exterior, and this is going to really shock you, of a circle is the set of all points outside the circle. Now a chord is a segment whose endpoints lie on the circle. And when I say on the circle, I mean on the edge of the circle. Please note, if it lies somewhere where it's just touching the middle of a circle, we would call that in a circle, not on a circle. A secant is a line that intersects a circle at 2 points. So a chord is a segment that is inside of a secant. An example, by the way, of a chord I just remembered to tell you is a diameter. A diameter is a very specific chord that you've already learned about. And the last of these terms that we are going to need to learn is tangent. A tangent is a line in the same plane as a circle that intersects it at exactly 1 point. So it only touches the circle once, as though you had like a plank of wood and you put it on top of a tire. The wooden plank isn't going to touch the tire at more than one spot if you just put it on top. So the point where the tangent and the circle intersect is actually called the point of tangency. All right, so now let's talk about a few more terms. The first one is congruent circles. Two circles are congruent if and only if they have congruent radii. Ooh, that sentence is biconditional. So in this case right here, if AC and BD are congruent, because AC and BD are both radii, or segments that go from the center of a circle to the circle itself, if those are congruent, then these would be congruent circles. So, next, concentric circles. So, concentric circles are very different than congruent circles. Concentric circles are coplanar circles with the same center. Think of a target symbol or the Target logo or the Looney Tunes logo or anything like that. Anything that is a target, basically. But concentric circles have the same center but will be different sizes coming out. Tangent circles are two coplanar circles that intersect at exactly one point. So they are not going to be concentric. They have different centers, but they are going to only touch each other once. So these will not become Venn diagrams or anything like that. They are separate. So we have internally tangent circles. Those are going to intersect, and one of them will be in the larger one. The smaller one will be in the larger one. And externally tangent circles are two circles of varying sizes, or sometimes of the same size at this point, that are not that are in separate spots mostly, whereas one is not inside the other. So now let's talk about the idea of common tangents. So in this case, A and B have two different common tangents. A common tangent, by the way, is a line that is tangent to two different circles. So line L is tangent to A and B on the top of both of them, whereas M is tangent to A and B on the bottom. Notice that these are on tangent on the same sides of the circles, on the equivalent portions. That would make them externally tangent to A and B because they are not crossing that center section, as it were. If I was to draw a line from one center to the other, they would not cross. Whereas if I change the picture a little bit, P and Q are also considered common tangents, but these are internal tangents because they cross at the center. So they actually will cross any line from one center to the other. Now for a couple of rules about tangents beyond that. So any line of tangency, any tangent line is actually going to be perpendicular to a radius that intersects at the point of tangency. So if I draw a radius from the point that the tangent line touches, it will be perpendicular to the tangent line. And by that same token, if I draw a radius that is perpendicular to a tangent line, then that must, in fact, to a line, then that line is a tangent line. So, there we go. If two segments are tangent to the same circle, and they end up meeting at the same point, then those two segments will be congruent. So, for instance, in this picture right here, AB and AC would be congruent because they are both tangent to P and they both meet at A. And they also create what looks like an ice cream cone. All right, so let's talk about what arcs are. But to know that, we actually need to know what a central angle is. A central angle is an angle whose vertex is the center of a circle. So a central angle of all things goes from the center. What a shock. An arc is an unbroken part of a circle consisting of 2 points called the end points and all of the points on the circle between them. So the arc in this case would be going from A to C and would have all the points on that red line in between them as well. Now A to C is what we would call a minor arc. A minor arc is an arc whose points are on or in the interior of a central angle. So the points A and C are on the angle, and the points in between are in the interior of that central angle. So notice that they are in between them in the middle of what would be the smaller of the two angles. So the measure of a minor arc is equal to the measure of its central angle. So in this case, arc AC, and we would name it after only the two endpoints. If it is a minor arc, is equal to the measure of angle ABC. Minor arcs, as I just stated, may be named by 2 points. But if there's a minor arc, you might be able to guess there is also a major arc. A major arc is an arc whose points are on or in the exterior of a central angle. So in this case, all the points except for what was the minor arc that we had in the section right before this, AC as it were. The measure of a major arc is equal to 360 minus the measure of its central angle. And we name major arcs as well as semicircles, which will be in the next slide, by 3 points. So in this case, if I was to have said, for instance, ABC was 70 degrees, then arc AC would have also been 70. But ADC, being the major arc on the outside, would be 360 minus 70, or 290. Notice that the major and the minor arc will combine to form a full 360 degrees. Now let's talk about the semicircle. If the endpoints of an arc lie on a diameter, then the arc is a semicircle. So if EG is a diameter, then EFG is a semicircle. Now the measure of a semicircle is half of a circle, which is 360, or 180. So in this case, the measure of EFG is 180. The measure of the other semicircle here, which we wouldn't name because we don't have a point on the other end, would also be 180 degrees. So now let's try this out. The circle graph shows the types of music sold during 1 week at a music store. All right, and yet I don't see Broadway standards anywhere on here, or soundtracks. I guess I'm not the only person buying music from this store. All right, so let's see. It asked for me to find the measure of arc ED. So ED is going to be the one that's right here. It's this purple section. It's country. Gross. Okay, so if I wanted to figure out how the measure of the arc, what I would end up doing is I would take the overall number of degrees in this circle, which is 360, and I would multiply it by the amount that ED is, which is 10%. So times 0.10, so times 10%, which gets us 36 degrees. All right, we have a couple of postulates here. The first one is the arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. I don't know why, but for some reason they call this ABC. They shouldn't. Looking at this, ABC is still very much a minor arc. So I would say AC is equal to AB plus BC. In a circle or congruent circles, the congruent central angles have congruent chords. So in this case, EAD and BAC both are central angles and they both are congruent. That means that DE and BC, the chords formed by those angles, would also have to be congruent. Now, if you have congruent chords, you also will have congruent arcs. That means ED is congruent to BC, so DE, arc DE, is also going to be congruent to BC. And finally, congruent arcs have congruent central angles. ED is congruent to BC. meaning that DAE is congruent to BAC. So in other words, if we have two congruent central angles, that means that the two chords that are formed are congruent, as well as the two arcs that are formed will be congruent. All three would be congruent. And if we have two random arcs or two random chords, then those will be congruent to each other as well as congruent to the central angle. Now, in a circle, if a radius or diameter is perpendicular to a chord, then it will bisect the chord as well as the arc, meaning the distance from E to F is cut in half by this radius, as well as ED and DF being congruent. Now, in a circle, a perpendicular bisector of a chord is also a radius or a diameter. So in this case, because JK is a perpendicular bisector of GH, that means that JK has to be a diameter. And in this case, AK would be a radius, as well as JA because it's part of the same line. All right, so now we will learn how to find the length of an arc using the measure of the central angle. So in this case, I'm telling you that the central angle is 36 degrees and that the radius is 10 inches. Now, the measure of an arc is equal to its central angle, so the arc would also be 36 degrees. So now that we know that, we can actually find the length of this arc as opposed to having to find the entire thing. So first we need to find the actual circumference. So we will leave this in terms of pi. So quick reminder, circumference is equal to 2 times pi times the radius. And in this case, we know that the radius is 10 inches. So at that point, circumference becomes 2 times pi times 10, since the radius was 10. And we know that 2 times 10 is going to get us 20. So we have the circumference is 20 pi. Now, since the arc is a part of the circumference, we multiply it by the ratio of the arc measure to the whole circle, which is 360 degrees. So we're going to write a ratio being, in this case, 36 over 360. So 36 over 360 and then times 20 pi. So 36 over 360 is 1 over 10, so 1/10 of 20 pi, which means in this case our answer would be that is 2 pi inches, or like 6.28 inches. But I like it left in terms of pi because decimals are bad and pi is good. Very good. All right, so now let's talk about sector area. So first we need to know what a sector is. A sector is a part of a circle that is enclosed by 2 radii and an arc. You might already be seeing in here, it's basically the equivalent to a piece of pizza where the arc is just the crust. So let's talk about how to do this one. The process of finding the area of a sector is pretty much the same as finding the measure of an arc. The only difference is measure of an arc was circumference, whereas for sector area, we need to do area. So we start with the area formula. Area is equal to pi r squared. And in this case, we know that the radius is 10, so we replace it. So it's now pi times 10 squared. 10 squared is 100. And then we do the exact same thing as before. We do 36 over 360 and we multiply that by 100. So 36 over 360 is 1/10. So 1/10 of 100 is just 10. So our final answer is that it would be 10 pi square inches. All right. Or I guess 31.4 if we wanted to give an improper and inexact number. And with that, I guess it's time to just like and subscribe. So yes, please like and subscribe, and thank you all for. Wait a second, I forgot. There's one more thing. That's right, we're talking about Radians. Now, for those of you that don't know what Radians are, I remind you of this. This is the screen that you can find oftentimes on calculators, and it is the format. It is where we had to go to change everything from radians to degrees when we were talking about trig. Now, I mentioned that radians were something that would be discussed later, and mostly in pre-cal, but I do want to talk about how we get radians today. So, first I'm going to show you this beautiful animated GIF that I've stolen from the internet. So let's say that we have a radius, which would be this amount right here. It creates an entire circle because every part of the circle is equidistant to the radius. Now, if I was to put that radius onto a circle, you would see that for me to get to half a circle, I would have 1 radian. That is the distance of just one amount of the radius. But then we would keep going. There's a second. And then we have a third. And there's a little bit more, about 0.14159, so on and so forth, that gives us pi radians for half of a circle. But the thing is, we have another half of a circle, which becomes 2 pi radians, which makes sense as the formula is 2 pi r. So now, whenever we talk about radians, we're talking about how many there are. So if I say 2 pi, that's the equivalent of 360. Or if I say pi, that is the equivalent of 180. So for any degree, we are actually going to divide by 180 because we're putting it in terms of pi. Remember, pi is 180 degrees. So in this case, we're going to go with 280. So at that point, what I'm going to do is I am going to divide that 280 by 180. Now, at that point, you want to use the fraction feature on your calculator to simplify the fraction. In this case, this has a common factor of 20, but that would be math enter on TI like 83, 84 devices. But in this case, it ends up becoming 14 over 9. But remember, that's in terms of pi, so we have to then multiply that by pi. So it's 14 pi over 9 is the 280 degrees in radians. Now, what if, instead of wanting to go from degrees to radians, we wanted to go from radians to degrees? Well, the first thing we do is we divide the fraction by pi. So in this case, it's 5 pi over 3. So we're going to divide that by pi. That cancels out our pi. Oh, that is the saddest thing to say. So we now have 5/3, and we multiply that by 180. So in this case, let's see. 3 and 180, that's the same as 60. So 5 times 60 is 300 degrees. And that is 5 pi over 3 in degrees. And with that, that's really about all the different things that I need for you to learn. So once again, the only thing left for you to do is like and subscribe. Thank you all very much. Without fan support, I would have never been able to finally make my true director's vision apparent for all the world to see. Thank you, and have a wonderful day.